Welcome. My name is Gururajan. I am with the Department of Metallurgical Engineering and Material Science at IIT Bombay. This is a course on phase field modeling. Phase field models are also known as diffuse interface models. In this course, we are going to look at microstructures and their evolution. We want to understand what microstructures are, how they form, why they evolve, and how they evolve. The reason why we are worried about microstructures is because any material, irrespective of whether it is a metal or alloy or a ceramic or a polymer, we process the material in some ways and then we use it in an application. Microstructure is the bridge between the processing and the application. So, the processing produces some microstructure and that microstructure has a say on the property of the material. For example, in this video, we see that you try to solidify a material. The solid that forms will form a tree-like structure that is known as dendrite. If you solidify ice, for example, from water, if you try to make ice can form this six-fold tree-like structure, the dendritic structure. So, in phase field modeling, there are three aspects. One is, of course, the material science aspect. The second one is to look at the mathematical structure. So, we want to pose this problem as a mathematical problem and solving the mathematical problem. So, we have three things to take care of. One is material science, the other one is mathematics, the third one is computation. In this course, we are going to look at all three aspects. The material science aspects will be there at the beginning as well as at the end. We will look at what the problems are and what the applications are. In between, once the problem is known, we want to pose it as a mathematical problem. Posing it as a mathematical problem will involve lots of mathematics, which is not typically taught in engineering courses. So, we will have some advanced mathematical topics like group theory and variational calculus, etc. So, we will do that. Once we get to the mathematical aspect, we will end up with a partial differential equation. These partial differential equations look like diffusion equations, but with slight modifications. So, these are modified partial differential equations of the diffusion type. Then we are going to solve them. For that, we are going to use a software called GNU Octave. It is a freeware. It is meant for scientific computing. It also has the advantage that once you solve the equations, you can look at the solutions using Octave itself on the computer screen. So, it becomes very easy to understand and analyze the solutions. So, this is what we are going to do in this course, to look at the material science, mathematics and computational aspects of phase field modeling. In this course, I have two TAs to help me. They are my PhD students, Mr. Arijit Rai and Ms. Kamalakshi. Both of them will help me and will help you in running this course and helping you learn these aspects of phase field modeling. Welcome, and I look forward to interactions with you on phase field modeling. Thank you.